seminar series. Today, we offer a unique opportunity for everyone to meet Professor Murat Saparbaev. Our speaker, an internationally renowned professor in the field of molecular biology and genetics, will give an in-depth look at how academic science is growing and how tenure works in French research institutions. We hope this meeting would serve a platform for your professional networking as well. Before we start, let us introduce update on our association. Halamjan, I pass the mic to you.
Yep. Thank you, Aya. First of all, can you hear me and see? Yeah, good. So thank you very much for joining today. Just briefly before our talk start with Siyek Saparbaev, quickly introduce our association. So we just recently rebranded our association name, Kazakh International Science and Technology Association. So we work globally with all scientists in a young career or established scientists, mainly Kazakh scientists, and try to form this good catalysis for discovery and innovation and be a platform. So today we have guest of honor seminar series. It's July meeting with Murat Saparbaev. Later, Serk Mirmanov will introduce our speaker, but as you know, previously, Murat Saparbaev is a very established professor in France in the field of DNA Repair and Carcinogenesis. And today's moderator will be Aya Yespolatova. She already introduced, PhD candidate in National Institute of Genetics and graduate student for Advanced Studies, Japan. So this is our team of our association. My name is Almjan Isabekov, Aya Yespolatova. I'm from Germany, Aya Yespolatova from Japan, and Professor Serk Mirmanov, project consultant of our association, also from Japan as well. So about our journey of our association, so we started from 2014 until 2024, already 10 years. We have different speakers from different countries in a different level of studies, PhD postdocs from Japan, United States, China, at Tsinghua University, Peking University, New Zealand. So we organized over 20 online, offline meetings featuring different Kazakh researchers working around the globe. And we also have second session where we have already established scientists. As today we have our guest, they're working globally in different universities, in the United States, in Europe, in Japan. So we will continue also invite them to this platform to share their experience. So shortly about us, Kazakh International Science Association, we bring together scientists, educators, graduate students to be a platform to have innovation and entrepreneurship in science and technology and to share this knowledge with everyone. Other than that, we're also trying to be a platform for academia industry, where here you can have opportunity to expand your pursuits, scholarly pursuits, and professional network. Our mission is to maintain, see, and develop common intellectual and cultural space of Kazakh scientific community across the globe, to provide experience in professional community and public on scientific and educational discoveries. So, and we're trying to initiate different projects and try to contribute to Kazakhstani science between all Kazakh researchers that working globally. So shortly, 2 months ago, our project coordinator, Serk Mirmanov, attended meeting in Akoda. I guess, actually, Murat Kaliyevich Saparbaev, also today's presenter, also attended this meeting. And mainly our association, it's actively trying to help growth and sustainable development of Kazakh researchers in Kazakhstan as well. So this is a short brief about this news. So as I said, we have 3 sections. First of all, monthly seminar series, where we inviting different established scientists working abroad and Kazakhstan as well. So last one, we invited graduate of Harvard School, PhD. Now he's already assistant professor, Qazaq. Other than that, we're doing panel discussion. We're inviting different speakers on a different level, mainly PhD postdocs, to share the common knowledge that interested for everyone. And also we have industrial talk, where we inviting people that working in industry after their PhD or postdoc. Last one was Amina Nursaliyeva, Anara Nursaliyeva. She's working in Roche, very famous pharmaceutical company in Germany. So we have 3 sessions. So we are actively trying to organize panel discussions. So last one, what we organized is about flooding in Kazakhstan in the spring of this year. It was pretty hot, terrible situation, and we invited international and as well Kazakhstani scientists that working abroad and also in Kazakhstan to give some solutions, recommendations, and also upload this to our YouTube video so everyone can take some knowledge from these meetings. And want to mention that we have this worldwide map of Kazakh researchers on our website, where you can easily locate scientists if you're going for conference or for other countries, just to know where Kazakh researchers, PhD, postdoc, or maybe established scientists working there. You can check it on our website. Here's a brief map in several countries. We're continuously adding them, mainly PhD, postdoc, and established scientists. And here's also another part in our website where we have this person of Kazakh origin scientists that working globally, and we continue adding them. So this is our website. This is I'm in Europe. Aya and Professor Sirik Mermanov in Japan. This is our website. If you have time, go ahead, visit it. If you have any recommendation or some, you can also write to our email. So today, so here I'm passing to Aya to introduce, and Aya pass to Sirik Mermanov. He will introduce our today's guests. Thank you very much.
Okay. Thank you. Aya, your microphone is muted. Okay. So thank you, Galmjan. Thank you, Aya, for introduction. So dear colleagues, hello. Thank you for joining our seminar. So it is with my great pleasure, I would like to introduce our distinguished guest, Professor Murat Saparbaev. He is an internationally renowned expert in DNA repair and carcinogenesis. Also, Professor Saparbaev, he joining us from the prestigious Gustave Roussy Cancer Campus in France, in Paris. With over 2 decades of experience in the French academic environment and 15 years of leading his research group at one of France's premier cancer research institutions, Professor Saparbaev's contributions to the field are remarkable. His work, recognized by the French National Center for Scientific Research with the Premier d'Excellence Scientifique Award, and has been published in over 100 high-impact journals and cited over 3,500 times. Professor Saparbaev's journey is a testament to the power of international collaboration and the pursuit of knowledge across borders. His origin is from Kazakhstan, where he began his academic journey at Al-Farabi Kazakh National University before making his mark on the global stage in France. Professor Saparbaev's research, focusing on DNA repair and mutagenesis, holds immense promise in understanding the mechanism behind aging and cancer. His dedication to nurturing the next generation of scientists is evident in his active involvement in training of PhD students and masters both in France and in his motherland, Kazakhstan. In this session, Professor Saparbaev will share his invaluable insight and experience, providing us with a unique glimpse into the world of cutting-edge research and international collaboration. His story is an inspiration to all of us, demonstrating the transformative power of science and importance of fostering global connection and the pursuit of knowledge. So please join me in extending our warm welcome to Professor Murat Saparbaev. Yeah, so I'm handing microphone to you.
Let me emphasize on our agenda today. First, Professor Saparbaev will give a talk for about 30 minutes. Then we would move to the Q&A session. We would like to ask our audience to write questions in the chat, and we will address each of them in the end of our session. Now, please join me in giving a warm welcome to the exceptional Professor Saparbaev.
Thank you. Thank you. Everybody hear me? Yes?
Yes.
Yeah, okay, great. So let's start with my slides. Maybe it would be better to start with slides. Just I would like to thank you, Serik, for presenting me and briefly describe my career parkour. So yeah, I graduated from Al-Farabi University. It was Kirov University at that time in 79 and no, 84, 1984. And then I spent 10 years in Novosibirsk, in academic city, where I got the PhD diploma, you see, PhD diploma, degree in 91. Then I move as a postdoctoral fellow to the to the Institute Gustave Roussy, France, you see, in 92 until 94. 94, 95, I spent 2 years in Galveston. Galveston, it's a small city on the coast of Mexican Gulf, yeah, in Atlantic Ocean, near, very close to Houston. And there was a Seeley Center for Molecular Science where I did postdoc with Satya Prakash, expert in genetics of yeast. And then I went back to France, where I continued to work as a postdoctoral fellow, and I participated in the concours, or competition for getting tenure position. It's something like NIH, maybe you know, system. So I got tenure position 98, and since then, let's say 96, and since then I work always in the suburb of Paris, which called Villejuif. In Villejuif, you have with Gustave Roussy, and started from 2001. I'm head of the group, you see, head of the group, and then I promoted to research director. I got this habilitation to supervise research, so I have postgraduate students, CSE for PhD student, and my main research interest like Serik told, is DNA repair and mutagenesis. I'm not an MD, you see, I'm not an MD. I'm really more interested in basic research, and I'm interested not only in cancer, human, yeah, but I also interested in other model organism like bacteria or plants, or also mammalians. And I study the molecular biology of processes which maintains genome integrity. It's so just some photo I would like to show you. It's Alma-Ata. It's not Almaty, it was Alma-Ata, Soviet Union. So I graduate, I mean, finished with school. I don't know how it translates. Средняя школа 39. 1939. It's if somebody of you been in Almaty, this school is near the old square. Old square where there was a ministry before in old square, and there was a parades. Soviet parades organized. So it was in center of Almaty. The school was in center of Almaty, and it was a mix of
Murat, where are you in this picture?
me. You see my mouse here? You see? Do you see? This is me. You see it, yeah?
Very smart face.
Maybe, yeah. So it's my class 10B, I guess. We had so you see the background was very good in Soviet Union because it was capital of Kazakhstan. It was a school at the center of Almaty, and there was a mix of kids from nomenclature, and kids from simple family, you see, was mixed, really mixed. But teachers were very good. I appreciate it. I got a good start, you see. I very appreciate now that it was a very good education, basic, very good education given us by teachers. Mostly Russian, of course. They are mostly Russian, but they really educate us very well. The only things they didn't educate us to speak Kazakh, but all other things was excellent. So then after Al-Farabi, I don't have photo of Al-Farabi University. I went to Novosibirsk after graduating from Al-Farabi University, thanks to Maya Hadjidin Shigaeva. She was a chair of biological faculty. So she elected me because I was a kind of smart student, actively participating in discussion, asking questions, etc. And she proposed me to go to make diploma work of 5th and 6th year of Al-Farabi University in Novosibirsk, academic city, where I met, you see, I met Sasha Mazin here, you see, here, Sasha Mazin. And Sasha Mazin worked with Rudolf Iosifovich Salganik, you see. Salganik was the chief of Department of Molecular Genetics. He was a член correspondent of Academy Science of Soviet Union, and he had access to the funding in Soviet Union because academic city was a kind of very high level of science, Moscow, and then it was go academic city. So it was very top level of physics, mathematics, and genetics in Novosibirsk. So it was a kind of scientific elite of Soviet Union was in that place. You see, this is our laboratory, and what is good with Salganik, he renovated. He really introduced molecular biology, molecular genetics in Soviet Union after Lysenko, you see. So I really got a chance to be in this collective. You see this collective? This is Dianov, my other two supervisors, Mazin and Dianov. This is me, you see. So this is our laboratory where I got my PhD. Then after getting PhD in Novosibirsk, I moved to Viljuiv, you see, suburb of Paris, you see. It's south suburb of Paris. It's very close to Paris, actually. You can go by metro. It's very close. And you see this huge building. It was constructed, I think, in 1970s. It's a huge hospital complex. They have a lot of, I think, thousands of beds. So from everywhere, from France and Europe and other country, people who get some cancer, they come to this hospital to get a treatment, specialized treatment. They also treat the pediatric cancer. The center which specializes in treatment of pediatric cancer is very important. You see this building here? It's 4-floor building which was constructed in 1980s, opened by Mitterrand. This is research building, you see. You have hospital, huge hospital, and you have near the research building. So this research building is, they accommodate the scientific laboratories from two entities, INSERM, three entities, I would say, INSERM, CNRS, and university. So this laboratory, which located in this building, we kind of obliged to do basic research, but which is linked to the cancer, you see. So kind of we want to bring basic research closer to the clinics. This was the idea, you see. This photo show that Gustav Razi is this guy you see in the lab coat, white lab coat. In the beginning of 20th century, some physicians they realized that cancer should be treated separately from other diseases, because before him, and not only him, but he was not only, before him, for example, breast cancer was treated by doctor who deal with breast, you see. Colon cancer was dealt with doctor who treats disease related to colon, you see. So cancer was treated depending on the organ by doctors. But this physician, Gustav Razi, realized that cancer actually it's common disease. It does not depend, I mean, the treatment can be the same for breast cancer or colon cancer, you see, and should be treated in the same, by the same doctor, you see, because cancer, it's a specific disease where you do not classify it by the organs, you see. So he really separated, he branch of medicine, which studies the cancerology, you see, everywhere in the world. So it was the idea with introduced in beginning of 20th century. So this is my other mentor. As I told you, first was Maya Khadjidina Shigaeva, yeah? I don't have Alpha-Rabians. Yes, then mentor was Salganik and Mazin. Then other mentor is Jacques Laval. Jacques Laval, he started to study DNA repair in 1960s. See, first with Thomas Lindell. Thomas Lindell got a Nobel Prize then. He also started with Thomas Lindell in France, and I took the lab of Jacques Laval. You see, after he retired in 2001. I took head of his lab, and he also helped me to get this tenure position. You see, he selected me because I was from Soviet Union. I had a good background, and I worked hard. And you see, in to some advice for young scientists here who wants to start career, it's very crucial, you see, to have a good mentor. You see. Mentor who appreciates your intellect, your motivation, and mentor who has a legacy kind of authority, and which is worldwide new. So it helps a lot because you are not kind of coming by your own without history. You see, you need always some history, but you don't start history from zero. You start history always from something. You kind of use the background foundation which was created by others, you see. This is very important in science. It also has drawbacks, you see, drawbacks. It's a system which we call agashka. So in science, it's kind of agashka, a system agashka. You need to find agashka. It's good or bad, I don't know, but it's, you see, it's how things are done. I mean, works in this world. It's not only, you know, talent, genius, money, whatever. It's really, you need to follow some history, you see, to have some legacy and to have some cover. You need to cover, you see. You need some cover. Without cover, you are exposed to everything, and nobody, because everybody would first appreciate you if you from somewhere, you see. Like in Kazakhs, you have Ru and Jus. If you don't have Ru or Jus, nobody would tell you that you are Kazakh. So the same kind of in science, you see, you say, I am from Jacques Laval's laboratory, or I was working with Salganik or Mazin, you see, or in Kazakhstan, I say that it's Maya Khadjidina Shigaeva who promoted me. So everybody knows, you see, we already kind of, it's a history. So 2003, this is my team in 2007, you see many Kazakh faces sent by, this is Roman Kulov who sent these Kazakhs. Lukbek Kairov, he's now a National Laboratory of Astana doing human genome sequencing. I forgot, he's from Eurasian University. This is Arman Kuloyasov. He is head of the Protomic platform in National Center of Biotechnology. This is me. This is students. This is Alexander Ishchenko, also tenure position coming from Novosibirsk. This is nowadays, it's 2008, you see, 11th. With Umut Ali Askarova. He graduated from Al-Farabi, but then she performed master studies in Paris, you see, in École Doctorale. She got a fellowship, French fellowship. She came to my laboratory with this fellowship, and she did PhD studies. She got a diploma, French diploma, and now she works as a postdoc in United Kingdom. See, very talented young Kazakh girl, which really came from Almaty, and she learned. She already knew the English. She also learned some Japanese. At the beginning, she wanted to go to Japan, but then she appreciated Europe and stay. She's now in now I forgot, it's somewhere in near the London. I don't remember, Sussex maybe, I don't remember. Okay, this is some aha moment, of my let's say long career, because it's starting from, let's say, from 1984, yeah. So, but most of research was done already when I was postdoc in France, you see, and the United States. One of the moment, it's Procedure National Academy, Procedure National Academy Science of USA. I published 94. We discovered some glycosylase, very important. 94 with Jacques Laval we published. Then I published my own paper in Nature. We discovered some interesting alternative nucleotide excision repair pathway. This was a remarkable discovery. Alternatives, we discovered some new mechanism, you see, of repair. Then in it was 2009, we also find that some enzymes which you call DNA glycolysis can repair the interstrand DNA crosslinks, and it was really a big discovery in biology. And recently in 2016, you see, we discovered what poly-ADP ribose polymerases. Before us, everybody thought that these enzymes usually covalently modify only proteins, you see, but we found it can covalently modify also DNA. With this aha moment, what's the last aha moment which I would like to tell you, because maybe it would be interesting for you. It's just kind of it's purely scientific, but has some philosophy, which is very important, because you see, all previous discovery and most scientists in molecular biology, you see, we use this reductionist approach. You see, reductionist, when you it's the idea, you see, to reduce in complex interaction entities to the sum of their constituent parts. You see, it starts from Descartes, French philosopher Descartes. He say that, for example, duck, you see, duck and non-human animals could be explained by reductively as automata. We are all robots, just constructed with proteins and DNA, but still robots, and we can disassemble machine and assemble again, you see, and everything, it works like in clock, you see. This is the idea that you can reduce complex things like life or computer, yeah, or brain to simple entities and interactions, and then you may understand when assembling how all system works. You see, it's a good actually approach. I'm not against it, and actually all molecular biology since Francis Crick dogma are constructed on this idea, reductionist idea. You see, that's why people was looking for genes, for structure of genes, which discovered by Crick and Watson, yeah. And then Francis Crick proposed this formula, dogma, which provides residue by residue mechanistic explanation of the flow of genetic information. So you have a gene, which is in DNA, which is transcribed to RNA. RNA goes to ribosome and gives you protein, you see. Protein has some function, metabolic, yeah. And this function gives you phenotype. And for cancer, you see, like Serik, of course, knows, you have some mutation in oncogene or tumor suppressor gene, you get a phenotype. Phenotype is a cancer, you see. And everything is nicely explained by this dogma, very nicely explained. So it's a great success of this dogma. I mean, reductionist approach, let's say René Descartes and then Francis Crick. Great success of this scientific approach of reductionism. But unfortunately, the reductionism is good and give us enormous progress in biotechnology and medicine, but still we have now huge problem treating age-related disease like cancer, Alzheimer, etc. And this approach, which work nicely, for example, for bacterial infection or even viral, you see, you get vaccination, you get antibiotics, you get antiviral, even HIV. HIV can be treated by a cocktail of drugs easily. Okay, so but when you do cancer or Alzheimer, unfortunately, it's not so easy. It's very time consuming and money consuming. I would say for one drug which comes to the clinical trial, it's companies spent about $1 billion, you see, nowadays, and it takes maybe 20 years of research. And usually, very often, these drugs are not much better than the old drugs, you see. So I just want to say that this approach, reductionist, may not always work efficiently. Why we go back to philosophy, you see. Always go back to philosophy. Maybe when you become old, you tend to think you tend to become philosopher, you see, because you cannot change world, you see. You always need to adapt to world. So that's why people become philosophers. Because what we wishes are not complementary. I mean, not always adapted to the environment, you see. We want to be rich, but we cannot. We want to be healthy, but we are not. So you see, so always we always reach in some compromises. It's a philosophy. So Karl Popper divided the world in two categories. It's very important for young scientists to understand, because two categories. It's a clock, you see, it's a clock, and clouds, which are not equal, of course. So if you go to clock are neat, orderly system that can be solved through reduction. You remember René Descartes and Francis Crick dogma. Clouds are epistemic mess, you see, clouds. Highly irregular, disorderly, and more or less unpredictable clouds. One day come, other day disappears, you see. Almost unpredictable. The mistake of modern science is to pretend that everything is a clock, you see. We want to believe we will understand nature if we find the exact right tool to cut its joints, you see. To disassemble this clock, we will understand everything. It's a big horror, but that approach is doomed to failure. We may live in universe not of clock, but clouds, you see. This you need to understand. And here just this aha moment recently, in collaboration with mathematician in Nazarbayev University, we published one paper in some obscure journal, because we tried other journals but nobody accepted us. And we kind of aha moment comes that actually maybe with genetic information which are encoded in our DNA, you see, it's 3 billion base pairs, you see. Only 2% of this genetic information transferred to the phenotype, you see, to phenotype, only 2% of this information in direct reductionist manner, mechanistic manner, that you can elucidate and find the drugs. But all other 98% are transferred in implicit manner, implicit. Even more, I would say contactless manner. This is idea, okay? So what else? For scientists, I remember you used cell. Do you have any advice for young researcher entering your field or academia? Okay, this is my advice. Take a role model. Take a role model. Who this guy you see? Sorry. You see on the left. Somebody can tell me who this one? Who is? Do you hear me? You know him?
No,
Do you know him?
unfortunately, we don't know. But it seems
No,
like
no, somebody
painter.
should know. No, somebody should
Picasso.
know. Picasso, great,
Yes,
great.
we actually
Painter.
have a audience answer Picasso.
Okay, because the
I know.
other in the middle. Who is the middle?
Van Gogh.
Bravo, Van Gogh. Bravo, bravo. And on the right side,
Should be
sorry.
scientist.
Who?
Should be scientist or mathematician. I don't know exactly.
Kafka.
No.
It's
Who?
Kafka.
Great, great. You see, you are very intelligent and you have encyclopedic mind, you see. This is a role model for scientists and artists, you see. What's the difference between these three guys? Everybody know Kafka, yeah? Everybody know Van Gogh and of course Picasso. So Picasso is very successful guy, you see. He can just spend one day and create a painting which he can sell for $1 million, you see, one day. 7 pictures, $7 million, you see. He created riches, wealth by from zero. He can create the wealth, you see. He works better than the what you say, oil mine, or what you say. Even better. You imagine. Very successful guy. Yeah? At the beginning, of course, he spent some harsh time. It's true. Civil war in Spain. He was very, you see, he was very poor, but then he learned how to sell his stuff, you see. And was at the end of life was very successful. And he left a lot of painting and opens a new perspective in the art. Van Gogh. This is model for everybody, you see. Sorry. Model for everybody. You can try to be him, okay? Nobody prohibit you, you see. No, you can. Most of young scientists want to be like Picasso. At least they dream to be. It's no problem. It's very good. The other model is Van Gogh. So Van Gogh was also talented, and his picture nowadays are sold for $100 million, you see. But during his lifetime, he did not succeed to sell even one picture. He didn't succeed to sell any picture of his work, any picture. He died in, I don't know, depression, mental disease, you see. But then people realized that he was genius, okay? So I thought that Van Gogh, maybe it's an extreme, it's really extreme. But surprisingly, I found even worse guys than Van Gogh. It's a Kafka. Kafka even didn't try to sell his things. Kafka even didn't try to sell his things. What he asked his friends, to him he left all his major things. He wrote some novels, small novels. He was, I think, working in journal, but his most well-known Metamorphose and Castle, yeah, he gives to left. After his death, he left for his friend and asked his friend to read and then to burn it out. It was his last let's say last asking, or what we say,
last words, yeah.
Last words, yeah. But his friend betrayed him. It's a big betrayal. He didn't burn his novels. He published it. He had many also women's in his life. And now with women's, or not with women's, but the kids or relative of this women sell the correspondence of Kafka with his lovers and get also many money from this, you see. So my question to young audience, for young audience, why Kafka asked to burn out his writings? Why Kafka asked? Tell me, please.
We have an audience actually typing in the chat, so we're gonna wait a little bit for an answer.
Why nobody wants to tell loudly? Loudly. Why?
Because of the meeting settings, I think. So Anil says, suggests, is it self-doubt?
Yeah, great, Anel. Anel maybe read something. It's a self-doubt, yeah. Exactly. Great, Anel. Great, very great. It's self-doubt. He thought that what his writing was nobody would appreciate, and it would be rather shame for him, and he did not want to publish anything. You see, it was self-doubt, yeah. So you can choose these role models or something in between. So, and remember, always remember, art is a lie which brings us closer to the truth. See, remember, okay? So, so I finish, and if you have questions or discussion, I can.
Thank you very much, Professor Saparbaev. It was a really interesting talk to see your career and the aha moments and your view on how to succeed for the young audience. I would suggest we move on to the Q&A session, and I would like to ask our audience to write any questions in the chat, anything you want to know from our speaker. If you have any career advice you want to get. While we wait for the questions, I'm going to ask the first question. So you already gave us some ideas, some advice for young researchers. If you would summarize maybe like top 3 things you would recommend for young researchers entering the field or what would be this 3 advice?
Advices, advices. What I can give you first, very important advice. You never regret your choice. You choose whatever you choose, doesn't matter, but never regret, never. If you choose, you follow. Take it like fate, not destiny. Destiny does not exist. There is a fate, you see. Everything in this world is fate, you see. So never regret. It's good. If you don't regret, it's good. Then always remember about Agashka system. I mean, Agashka, it means maybe it's exaggerated, yeah? Maybe it's exaggerated, yeah. It's kind of seems patriarchal, whatever. But actually, the human relationship counts a lot. You may be genius, yeah. You may have brilliant mind, but if you do not have empathy, if you do not feel feeling of others people, you see, I mean, if you are not able to communicate and sell yourself, you see, you would never succeed. You would not. That means Agashka. It doesn't mean that in Japan is also Agashka system. Hierarchy. So you need to deal with people. This is very important. Don't always rely upon your excellence or brilliancy, IQ, etc. It's nothing. It's nothing. So it's always human relationship counts a lot. You construct it. You construct it. You start to construct it from young. So always keep good relationship with every people. Try to keep, of course. Of course, you should also take some moral position, but do not go to open conflict, especially in West. In West, better not to go to open conflict because you are foreigner. You are not one of aborigines. You see, never go to open conflict. That's sure. And third advice, of course, it's motivation. And you see, there is a link to my interview in Kazakhstan, I guess. So it's a science or art is a sacrifice. You see, we sacrifice. It's sacrificial, human sacrificial, like at Aztec. You know, we sacrifice 10,000 people per day just to bring the rain. You see. So science is also kind of, because all you know, ways how science went through. Yeah, it's a lot of kind of symmetry, symmetry of unknown postdocs, unknown students, unknown PhD students who did most of the work, you see, but nobody remember them. We only remember Nobel Prize winner. Nobody remember who done all this stuff. Nobody.
Thank you so much for your advice, Professor Saparbaev. We have actually one question so far from our audience from Zairagu. Please, Zairagu.
Yes, I'm here. I'm here. It was very interesting to listen your way. Thank you so much. I really appreciate it. And also, I'm working on cancer treatment.
Okay. Yeah.
But in vivo model. And it was really interesting. I'm now studying in Budapest. I'm doing my PhD here. I have one question. I want to do my like postdoc after my PhD, and I would like to ask, where is the, I mean, the Europe is better or USA? Which
is better?
Yes, which country is better for postdoc work? I mean, yeah.
When I came to France, I did not want to stay in France, for example, because the language problem. I learn English in Novosibirsk and Kazakhstan. You see, my foreign was English. In France, it was very difficult. So I wanted to, because most of my colleagues from Siberia went to US, and I wanted to do. Actually, US, it's a place where maybe 90% of scientific information are created. You see, most of research are going on in US. You see, and some in Europe and some in Japan, of course. But you see, US is highly competitive, and there are a lot of pressure. Maybe for young people it's okay, more pressure, better. The problem with US, it's for family. You see, you need to pay for education, you need to pay for health, for assurance. You see, and it's very there is no any socialism in US. There are a lot of kind of difference between poor and rich. A lot of. I never see so many obese people in any other country, like in US, and it's not good. I don't know, but to do science, yeah, it's most good place to do science in US, and they accept everybody, and you have all over the world goes to US to do career. Maybe it's good to go to US. Yeah.
Okay, all right. Thank you so
But
much.
in perspective, you see, I did my career in France, and luckily I escaped US prison.
Okay.
But
I'm also
chances are in Europe, there are less chances in Europe, but there are
Uh-huh.
some good things that you can profit your life in Europe, but you wouldn't profit your life in US. You would succeed, you would be successful, but you wouldn't enjoy much, I guess.
I see. Okay, I understand what you mean. Thank you so much.
Thank you so much, Zarago, for your question, and Professor Saparbaev for the outlook, your outlook on the postdoc in different countries and different parts of the world. We don't have any other questions from the audience, but we do have other question about how would you summarize the academic science landscape in France, for example, and what are the tenure tracks in French research institutions?
Yeah, actually, the European science, you see, like Germany and France and Soviet Union are kind of, we have similarities, I guess, because I think Soviet Union and Russia adopted system from Western Europe, you see, with this habilitation to supervise research is coming. It's a degree of you have PhD, and after PhD you have second degree. You say doctor of science. You see, yeah, but it's actually habilitation. Habilitation is doctor of science, and you see what is difference between, for example, Anglo-Saxon and Europe. But in Anglo-Saxon, university are very strong. We have very strong research are very strong. Whereas in Europe, in Soviet Union, Russia, and it's also Kazakhstan, most of research goes to academic institution, you see. Some institution where people do mostly the science, we don't teach. Whereas in US, science mostly done, at least university usually group leaders, we do some teaching, but not so many. So we consecrate a lot of time for research. And that's why the teaching coupled to research may be the best teaching, I think, because you are not just lecturer, you also doing science. You can, and students would learn more, of course. In Europe, you see, in France, there is this academic institution you call CNRS, Agency, Central Agency of Scientific Research. We do mathematics, physics, biology, everything. Okay, and we have some tenure position, like NIH. We have tenure position where we do the concours. There is jury, and if you publish well, and if you have good agashka, you can get a position like me, you see. But nowadays it's changing, and nowadays we turn to the other system. So first you need to compete for a grant which you call young group leader. So young group leader, if we have good CV, yeah, we can write a project. We can find a laboratory in France which can accommodate this group. So this young group leader gets money for 5 years of research. And usually if we won this grant for 5 years, yeah, as a grant, as a group leader, usually it's postdocs from US or from other countries, you see, with good publication list. If we submit a project and we got funding for 5 years research as a group leader and have some laboratories which can accept them, during this 5 years, we have a good chance to enter to tenure position. In Sermos and RES, or also as INRA, we call INRA. You have also EDF, other system. University, we have a lot of position. We call it maître de conférence. Maître de conférence, it's like our lecturer in Alpha-B. It's a lecturer position, which is also good, but 80% of time we do teaching. We don't do much research and not much publication we can do. It's very tough. For them, it's very tough because if you do 80% of your time you're teaching, you don't have time. And usually you don't have laboratory, a good level of laboratory at university. So we usually with university lecturers, which you call maître de conf, we usually go join some CNRS or NCM laboratories where we do part of our job and we go teaching, we go to lab to teaching like this, you see. This is, I would say, landscape of science in Europe, which is kind of old, is not kind old one, you see, is not very much reformed. And what else? What is good in Europe? I think is good. It's more human because I would say in, for example, in US, you are successful. You see, you have associate or assistant professor at the beginning, and you win some grants, grants, NIH grants, other grants. And from these grants, you get your salary. Most of your salary comes from these grants. But then if financial crisis occurs, or if your field of research are not very competitive, they cut your grants. Yeah, but you have credit to pay for your house. You have money to pay your kids for education. And you also have health assurance, you see. You lose everything. You lose everything. You imagine how people live in US. You imagine the stress which we should overcome and survive. Yeah? Whereas you see in France or Germany, your salary comes independently, like in age. You got salary. Salary is enough for living, for pay credits, etc. And but to do research, you need to compete for grants. You see, this is kind of more human and less stressful. Maybe it's also, would say, not very competitive because some people profit. They just got the salary and do very little research. It's also possible. It's a drawback. But the drawback of US is more harsh. It's very harsh.
Thank you, Saparbaev, for this extensive answer for this question. We have a final question from our audience. Anil asks, what are the undergraduate research opportunities in Europe? What are the prospects for undergraduate students to be involved in academia in any way?
Undergraduate, you mean the master
Before,
studies or what?
Just
Before?
bachelor's degree.
Bachelor's degree. My nephew, he go to Alliance Française, you see, because I was in France and my brother sent his son to the France because I was in France. So from Alliance Française, he entered to the Polytechnical University in Marseille. He was studying energy, you see. It's to be engineer on energy power station, you see. And through Alliance Française, he entered to this university. I think it's very easy to enter to a university. He finished Republican Mathematical School in Almaty, actually. And
what about research experience? So not studying and in the undergraduate school, but some research experiences. Maybe internships,
internships,
fellowships, any other coursework.
Usually, Umit somehow entered to the master studies, 2 years of master study. I think it was a program between Alpha-B and France. She came to France was financed, I think. for 2 years study at in the France, and after 2 years study in France, and she did internship in my laboratory. She participated in competition for fellowship, PhD fellowship, and she won one of the fellowship. And she did for 3 years. It gives only 3 years, very short, actually. In United States should be at least 5-7 years, but here it's only 3 years. And during 3 years, she did nice work, and she defended PhD and went postdoc in UK. See, and she finds there are some. You can come to master studies in France or Germany. You can find. Just need to go maybe Alliance Française, for example, for French. There are many ways to enter to master studies. Nazarbayev University, I think after bachelor you can go master to any university. I guess. So you can enter to master, but you need, of course, you need some money to finance your stay. But they usually offer you a student hostel, and the price of living is not very expensive. My nephew spent 10,000 euros per year. It was enough. 10,000 euros per year, it was enough.
Do your department or your institute offers any summer undergrad internships or semester abroad?
Yes, we offer, but you see, this is kind of, it should be done through the university. They should subscribe to university, to master program, to do some, if they subscribed through the university system. So we got some lectures, courses, you see, and then we choose the laboratory. So I am at the end of this. I accept students for 6 months or 2 months of internship, 6 or 2 months. But the rest of the year, you see, we do study in university, going from courses, whatever. So you need to find the university which opens the master program. So first you do master program, then you during master program you need to find a laboratory which accepts you. Nowadays it's difficult. It's more difficult than before. I know that many people from Maghreb country, Algeria, Morocco, Tunis, Egypt, many students want to come as a master. They subscribe to master studies in France. And then some of them get the PhD, or they stick to the France, they find some jobs, like this kind of immigration. But many students from Maghreb comes, and I had some Maghrebian students, very good, very excellent. But for them it's very tough because the competition is very tough, and to get the PhD, I did not succeed to get PhD for my Maghrebian students. But somehow I succeed to get PhD for Umit, for Kazakh girl. I don't know. But she was good in interfering with people. I mean, she was really open, and she learned French, and she presented very well, and she was really appreciated by commission. You see, it's kind of human to human. She knows how, she knew how to sell her.
The communication, the power communication,
yeah.
right?
And of course,
Thank you so much for your answer. I think we would like to wrap up our session today. We are so excited for audience that had a chance to ask you questions. We are thankful for our speaker, Murat Saparbaev, for talking about his unique journey and advice for young scientists. And I would like to invite everyone for our next honor of speakers session next month, and I'll see you again soon. Bye bye.
Thank you.
Thank you,
Thank you,
Murat.
everybody.
Thank you.
Thank you for your questions. Thank you for invitation and organization. Okay.
Bye bye. Thank you.
Bye.
Bye bye.
Thank you. Bye.
Okay.
Thank you.